Hi guys, it's almost Halloween and I want to show you a design I made some couple of years ago. Of course, an older design. I have quite a few of them and that I will show you in the future. Today we have something that will replace or could replace this. This is a DVM module, a cheap one from China. Let's zoom. I don't know if it works. I have a new equipment here. These things are very cheap. Accuracy, yeah, well, okay. You get what you pay. This is just a couple of dollars. They come with a variety of firmwares in these chips. It's probably a C51 generic something compatible chip, 8-bit microcontroller with an embedded ADC, 10 bits or 12 bits. They come as DVMs alone or a combination with for current and voltage measurements. But as I said, they came in so many different options with different firmwares that is quite difficult many times to say what you get. Few of them have a fixed resolution, others have an automatic resolution. When a value is reached, it changes the resolution, etc. I used quite a lot of them, but I had times where I wanted to do something different. Where, for example, I had the one for the range I needed, but it didn't change the resolution. It just had the fixed resolution. So when the value was lower, the accuracy was gone. Yeah. So the idea was, for these few reasons, for these few situations where I couldn't find anything that matched my needs in this price range, I would design something by myself. I wanted to keep the form factor of the bezel. This is the middle one, I think, yeah. It's 0.56 inches. It's good enough, the size is good enough to implement a different motherboard, a different board with electronics. So by using only the bezel and the plastic, the glass, I made this. This is a microcontroller based one at Mega 328 P or PB, depending on what I have at the moment or what I get. It is exactly the size of the main board that is used on from the China one, from the China panel meter, but it has a lot of electronics additional on it. For example, I'm using a 5-digit display. Of course, I could use another one, but why, if I can use a 5-digit one? This thing is completely programmable from the Arduino IDE environment. It has an ICSP connector. That means I have partially the SPI bus already broken out with that. I have MSOP10 clock. I have the reset signal and plus 5 volt and ground. Additionally, I have a header here for an external I2C daughter board that would sit on that part. That means that it will be mounted on this header and on this header. That makes it quite stable. With that, I could use external other I2C chips, like for example an INA229. That's a current and voltage, a shunt sensor from Texas Instruments that communicates through I2C to the microcontroller. On this board, I have already populated, this is the base board, this is the base canvas for everything that, for every modifications or additions I will make. On this I have an ADC converter. It's my MSOP10 It's from Microchip, I2C. It is 12, 14, 16, and 18 bits configurable, choosable by software. It is an integrated BGA, programmable gain amplifier, and an internal reference. So everything on this SOT, this small SOT 236 chip. In addition, there is the voltage divider input network with these two resistors that go up to 1206 or MELF resistors. And I added an SMD trimmer for the fine-tuning. The analog input is from this terminal connector, terminal socket, screwable, it's screwable. Power, this thing can be powered either from the 5 volt dedicated power connector, that's an GSD XH, I think, 2.5 millimeters pitch, or directly from the onboard USB. This is quite a small USB and vertical USB connector that I added, including this CH. I don't know if you can see it. No, it's on the wrong side. Here. This is a 330 CH330 chip. It's an USB to serial bridge. It's a very small one, the smallest I could find at that time, without going down to QFN. The power supply section with filtering. The LDO is not populated yet because I'm just in the testing phase. This here you can see, because I had some space here, and added a very small tactile switch that can be used for whatever. There is an RC debouncing on that. Can be used for whatever, some kind of save settings or a mini menu, etc. The idea is to have this, so in the case that I cannot find anything that is in this leak, I can use my solution and implement my specs with my own code. Additional to the I2C capability, of course, with the daughter board, you have, because you have the ICSP already broken out, This ICSP, that's a standard 6-pin 2.5 millimeter header, in combination with this header, with the I2C header, that is just labeled I2C, there are just 2 ports connected to the microcontroller. The microcontroller can be configured like that the SDA and SDL data and clock from I2C are used as normal digital outputs, for example, chip select. So that means that you can use these 2 as chip select. So you have on this daughter board, you could have up to 2 SPI chips, or complete a whole range of I2C chips. This thing is quite small. I was thinking to use a QFN version of the ATmega, but for the sake of to be easier for anybody to solder it, including myself, I used this package that is very easy to solder. Let's take a look what the ADC is capable of. This is the ADC I'm using. It's a fairly low cost ADC. It's up to 18 bits with the onboard reference, PGA with a programmable gain 1, 2, 4 or 8. It's a very small, it's a SOT236. And this is already provisioned on the main board. That would, for example, give me a quite precise DVM for up to 18 bits. This is the bezel I mentioned. You can buy this on AliExpress or eBay. 0.56 inches. It's exactly the ones that the China manufacturers are using. Just for test reasons, I uploaded a small demo program that I want to show you now, just to see if everything is working. This is how the demo looks. It counts 3 times from 0 to 9, so I can see all the segments, if all the segments are working. I'm shifting the decimal point from left to right in the background, and after all the decimal point from 0 to 9 3 times, I'm just writing random numbers on the display. So this is just a demo, a small demo, so that I can see that everything is working. The design files and the demo code, Arduino code, is available on request. If you like my videos, press the like button and please so it makes it easier for me to show you these kind of things that I made and I will make, and you help the channel to grow. Thanks guys, bye and have a nice Halloween. Cheers.